In the face of rising global warming, governments worldwide are tightening automobile emission regulations to reduce carbon emissions. To meet these strict regulations, the automobile industry has turned its focus to making lightweight vehicles. This includes lighter cars, railways, airplanes, drones, urban air mobility, kickboards, and bicycles. In this regard, magnesium alloys have garnered significant attention for developing lighter automobile components. Magnesium is the lightest known structural metal, and recent studies have shown that magnesium alloy products made by the extrusion process exhibit excellent mechanical properties and are suitable for the development of automobile body and chassis components. Moreover, magnesium is renowned for its excellent castability, machinability, recyclability, electromagnetic shielding, and damping capacity. However, commercial magnesium has Mg17Al12 and Mg2Zn phases, whose melting during high-temperature, high-speed extrusion leads to the formation of hot cracks. As a result, currently available magnesium alloys are not only expensive due to their slow extrusion speed, but also find limited use due to their low strength. To address this, researchers from Kyungpook National University Industry Academic Cooperation Foundation have presented novel BA56 magnesium alloy. This alloy, with bismuth and aluminum as alloying elements, offers both excellent mechanical properties and extrudability. Bismuth is a key element that thermally stabilizes materials and can improve extrudability and further improve strength through aging treatment, making the alloy suitable for high-temperature extrusion. Aluminum enhances the mechanical properties of magnesium alloys through solid solution strengthening. Additionally, BA56 allows the incorporation of one more alloying element to improve properties. Manganese can provide increased corrosion resistance, and zinc can further improve the mechanical strength. The BA56 magnesium alloy can be extruded at high temperatures of up to 450 degrees Celsius without hot cracking and at high extrusion speeds of up to 80 meters per minute, 10 times faster than commercially available magnesium alloys. Therefore, BA56 has high productivity, making it less expensive than existing alternatives. This groundbreaking material can be applied to various forms of mobility, reducing exhaust emissions and paving the way for a greener and cleaner future.